Hello, welcome to EthanAcademy. Today we're going to learn about points, lines, and planes. This is a point that has no dimensions. It is represented by a dot. You would call this point A. This is a line. So at any 2 points there's exactly one line. You can name this line AB, BA, CB, or AB with this symbol. However, if C, the line does not extend indefinitely through C instead of ending right there, this would be a ray. You would call this ray CB or CB with the symbol. When you name rays, you want to make sure that the endpoint is the first point that you list. If you have AB and it stops at A and B are both endpoints, and this will be line segment AB. If you want to name this, it will be line segment ABBA, or you could have AB without these arrowheads. This is the plane. Throughout any 3 points, there is exactly one plane. You can name it based on its points, such as plane ABC, or if it's labeled plane M. Planes are 2-dimensional, unlike lines which are 1-dimensional. Any points that are on the same plane are referred to as coplanar, unlike lines where any points on the same line are referred as collinear. This is an intersection of 2 lines. Lines always intersect at exactly 1 point. So, in this case, the lines intersect at point A. This is an intersection of 2 planes. They always intersect at 1 line, and they share all these points in common. So in this case, line AB is the point of intersection.
Hi, this is ChanCourse, and I'll be teaching lesson 1.2, which is the use of segments and congruence. First of all, to start off, a postulate, which is a rule that is generally accepted without proof. And here is an example of a postulate. Here you have a number line with points A here and B here. And the coordinates are x1 here and x2. So this is one postulate right here. So you have coordinates. And you want to find the distance between A and B, you would have to find the absolute value of x2, the coordinate of B, minus the coordinate of A. So that is the distance. Okay, so the second thing is, when there are 3 points that are collinear, which is 3 points that lie on the same line. Here you have A and C, and then there's B. So they're collinear. You can say that one point, which is B, is between the other 2, which is A and C. And here is another postulate. If B is between A and C, then the distance of A to B plus the distance of B to C would equal to the entire thing, which is A to C.
Hello, welcome to RahmanNoodles with Abdel Rahman.
So I will be doing section 1.3, use midpoint and distance formulas. And I will begin by explaining that the midpoint of a segment is the point that divides a segment into 2 congruent segments. So for instance, if this is segment AB, point M would be the midpoint because it divides it into 2 congruent segments. So for the midpoint formula of segment AB, in which A is x1 and y1 and B is x2 and y2, the formula for the midpoint would be x1 plus x2 over 2 for the x value and y1 plus y2 over 2 for the y value. For the distance formula, AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared if A has the values x1 and y1 and B has the values x2 and y2. An example of this would be for the points 1, 3, and 5, 6. And if you do the math, you get 4 units after plugging in the x and y values, and that is the distance in between these 2 points.
Hello, welcome to EthanAcademy. We are going to learn how to measure and classify angles. So this is just an angle diagram right here. So this is WXZ, angle WXZ. It's always important to make sure that X is in the middle of any angle name because X is the vertex of this angle. So it can't be ZWX or WZX. Notice how that if you add the angles WXY and YXZ together, you will get WXZ. This is called the angle addition postulate. Now, let's move on to congruent angles. If you see this part of circle, that means that the angles are congruent. So ABC is equal to the angles X, Y, and Z. When you denote that something is congruent, you use this symbol. So now let's continue on with congruent angles. Notice that how WXZ contains two congruent angles and that they share a common line or ray, XY. So seeing this, you can say ray XY bisects angle WXZ.
Hi, and welcome to another episode of Theology with Raymond, and today we're going to talk about Chapter 1.5, Angle Pair Relationships. So, the two main angle pair relationships are complementary and supplementary angles. So when you hear complementary angles, that means there are two angles that add up to 90 degrees, and when you hear supplementary angles, which is a straight line, add up to 180 degrees. So, as you can see here, this right angle has two angles that are complementary because they add up to 90. So we would say that angle ABD is complementary to DBC because they both add up to, again, 90 degrees, 60 and 30. Taking a look at the supplementary angle, we would do just the same thing. If they were 180, if they added up to 180, we would say angle FGI is supplementary to angle IGH because they add up to 180 or vice versa.
Hello, I'm Vihart, or Vihart, and today I'll be classifying polygons. A polygon is a closed plane figure with two or more sides. These sides are connected to two other sides at its endpoints. Polygons are classified by how many sides they have. A three-sided figure is a triangle. There are many names for a four-sided figure. A five-sided figure is a pentagon. A six-sided figure is a hexagon. And so on and so forth. The sides of a convex polygon will not cut the polygon when extended. On the other hand, the sides of a concave polygon will do so.
Bucka, 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 bucka.